and welcome back to Research Methodologies. This is a continuation of the research design lectures, and in this lecture I'm going to talk about the conceptual research design, so the design before you actually start planning your research. During this lecture we will look at how you design this concept, so we're looking at the modeling of the content of the research. We will determine what, why and how much is going to be studied, and we'll look at those four phases that we've talked about before: the objective of the research framework, the research question or the conceptual model, and the definition or prioritization of such things. So, how is this all going to work? Well, the first thing that you need is context. Let's assume you're going to study flying. So what is it that's flying that you're studying? Of fighter jets or of geese. So it's very important that you need a context for your research. In which context are you carrying out the research that you're doing? Because without a context, your research becomes unstructured and you're not actually solving the problem at hand. So you need to make sure that you have a good idea in what context your research falls. That involves asking questions, talking to the clients or your assignment giver, or when you create your own assignment, look at with the context for which you're solving this. So that's a very important one to take in first of all. The second thing we need to start looking at when it comes to context is that most of the time when you do research, especially for your master's thesis, you're solving somebody else's problem. Somebody has an assignment that you like, either because you get paid for it, or because it's something that you're really motivated to do, or because you really always wanted to do something for that company. All those sort of things come in there. This applies really to both people who do their thesis work within a company, but also who do a thesis work for a supervisor, because then you usually work within the context of their research line and their ideas of where they want to go. And it's very important then that you solve the right problem, that you actually understand what it is that they would like you to solve. So it's really important that you understand the context of the problem and formulate it clearly. One of the ways to check that you've actually understood the context is to, once you've been given the problem, is to go back to your supervisor or your client and say, okay, the way I understand it is that I have to investigate this, this and this. Am I correct? That is one way of checking that you've actually understood them and get confirmation that what you're trying to solve is the right thing. So for me that means make sure you communicate, either face-to-face or by email, but make sure you have confirmation that you've understood the context before you start going on to the next step. Let's try and illustrate this with an example. An airport has been told it produces too much noise. So it comes to you and says, can you find a solution to our noise problem? This is a dangerous one. What is the context? What noise? Are we talking noise of aircraft engines, which is probably what we, with our vision, through our aerospace lens, is what we're looking at. But it could be that they're actually having a problem with the noise of the cars and that they are at the wrong faculty. So in that sense, ask the question. And we're talking about what noise? Is it the noise immediately for the building, the aircraft building, or is it the noise that is caused by the people living 20 kilometers away? Because it depends which area of noise you're addressing and what the type of problem is, the type of solution, and where you're looking for. So it's very important that you answer all these questions and that you get a good idea of what is actually expected of you. And with that, we don't mean what do I have to do, but more a case of what is the real problem here and how can I help solving this problem. So then we have to talk about things such as scope and context. Right, so we have the context and then you have the scope. And in the scope, what you see is the scope is everything you bring to the table and the context is everything from the problem. And if all goes right, they overlap. And that overlapping area is called the research space. That is where the collection of your abilities and the context of the problem overlap. If these two don't overlap, then this isn't a project for you. However much you like it, you won't be able to do it. Another thing that can make a project out of scope is if they want, for instance, for you to do this for 3 years. A master's thesis only lasts 7 to 9 months. So again, then the project is out of scope. Another reason a project can be out of scope is because they are about an area that is outside your area of knowledge or the area of knowledge of expertise of the supervisors here at the university. It is important that your academic supervisor can support you and provide you guidance, and not just on a process basis, but also on a content basis. So all of that defines your research space. And within that research space, so you've limited your scope and your context together, you then have to define what your objective is. What is it that you're going to set out to do for the next 7 to 9 months? And this research objective is something that you really need to take some time to formulate, because it really sort of defines your scope, context and lines within which you need to encapsulate your research. So what are criteria for research objectives? The first thing you need to look at it, is it useful? What is the benefit of your research to the problem and solution? And what are you going to contribute towards the question from your client, be it the supervisor, be it the company or the institute? Is it realistic? In terms of how will it contribute to the solution of your problem, and can it be done? Feasibility. Can it be done within the time scheduled and within your capabilities and resources? It's great if it can be done, but if your research is going to cost 200,000 euros, I have to tell you that it's very unlikely that any company or the university will allow you to do that. Is it clear? Be precise in what your project's contribution to the problem or solution is. And this is an important one, because if it's not precise, you will forever come back to your research objective whenever you get stuck. Was this or was this not part of what I set out to do? There will be many temptations on the way and lots of ideas coming out, because we as supervisors love research, so we always have brilliant ideas coming into our heads. And at some point, it's up to you to keep us to task going, no, that's indeed a great idea, but within my research objective, this does not fit. If your research objective isn't specific and clear enough, then you also don't know, and you end up going up the garden path for a while, and then you have to come back and you waste precious times. And it should also be informative. It should give you a rough idea of what knowledge and the knowledge generated towards a solution. What is it that you are going to contribute in terms of knowledge, etc. So when you formulate an objective, you really must ensure that you can actually answer these questions. So basically, as any good engineer, we like a formula. The formula for a research objective is, the research objective is A by B, in which A stands for the contribution of the research project to the solution of the problem, and B, the description of the way the contribution will be provided. If you do not have B, statement A is too generic. The research objective is to conquer the world. That's a great idea. By what means? You're not telling anyone. Sounds a little bit like certain politicians. I shan't name names. But on the other way, if you said my research objective is to create a finite, sorry, it's not a good one, I'm turning them around. My research object is to provide a accurate prediction of the failure mode of a certain shell that buckles by testing a number of shells and creating a finite element model to validate the results. So then you've actually said, I'm fixing this problem and I'm doing this and this. End of story, nothing else. And that gives you an idea of how close that is. And with that, you cordon and off and you put boundaries in what it is that you're going to do. So, what types of research are there? This is again a little bit theoretical, but it helps you in terms of how you're going to look at research questions, for instance, later on. So, if you look at research, typically there are two types of research: theory-oriented and practice-oriented. The theory-oriented is usually about more the theory development and the testing of theories. Is it true that? Or, I'm seeing something, can I put a mathematical model towards what I'm seeing? How do I develop a theory from my observations? Now, this of course goes way back when, like thousands of years back, when the first scientists of the world started to do this, but it still happens today and it gets more complicated all the time. Practice oriented tends to be that you interfere in something that is ongoing. And in every product, every item that you work on, aircraft, spacecraft, satellite, etc., it can be in different phases of a project or different stages of the use of such a machine that you interfere. So we have problem analysis, diagnosis, design, change, and evaluation. In the next few slides, I will go into depth in each of them to explain a little bit what it is that we mean by that. So in theory development, we're really looking at developing theory based on what we see and measure, etc. So how is it possible that birds can fly? In this case, have a look at the flying dinosaurs. The objective could be to develop a theory about generating lift from the moving wings of a bird by measuring their wing and anatomic analysis of the dynamic motion. This is actually research that is ongoing at the University of Southampton, where TU Delft alumni is actually actively modeling to see how birds in the prehistoric ages, in the dinosaur times, flew. So in that sense, this does still happen. Theory testing is where you actually test a theory. Like, I have a theory that there's a relationship between the cost per kilometer in a car and the total driven kilometers. And is this relationship significant enough to reduce traffic jams? That's the theory. Well, the research objective could be to find out if the relationship exists between kilometer costs and driven kilometers by testing that hypothesis that I've just put in front of you. How you do it? That's the next step. But for now, that is what your objective is. You want to find out if something that somebody claims is true is actually true by a certain means. So that is where you have to be very specific. You will also be downgraded for this course if you do not have the by part in your research objective. The practice-oriented research is really about the intervention cycle. If you look at a project, generally speaking, it has all these phases. And at some point in the phase, you come in to solve a problem. And this is a tug of war, basically, between the current situation and the desired situation. And at each of these points in time, you can actually intervene and do things. So let me give you a few examples. In problem analysis, we would like to go to Mars. Is it possible that we can make it there by 2020? And then your research objective could be to make recommendations on what technical developments must be made in order to travel to Mars by 2020, by mapping out the technology ready levels of currently development. So then you've basically limited to what you are going to do. You're not going to design the entire Mars mission. Different thing. In diagnosis is, can airports compensate, that's the question the client has, for the improvements in IT which causes that it's no longer needed to be on the airport 3 hours before the flight? How can airports do this? By thinking of the revenue generation. So airports have earned less money from people that being there because they're there shorter. So they're not selling as much food and drinks and shopping and all the other stuff. So the objective for your research could be to come to recommendations to increase airport revenue by analyzing, so you're diagnosing what passengers want from airports these days. So you're actually going to look at, okay, we've already established that there is a loss. But have we actually asked what these passengers that are there shorter would like and where they would like to spend the money on or what they're willing to pay for? Then the design. This is probably closest to home of the more practically oriented engineers, but this is a real question. How can we reproduce the sound of a Ferrari using composite materials for the exhaust instead of the usual metallic materials? So the research objective could be to suggest a possible solution by designing an exhaust using composite material that has similar acoustic behavior as metals. So it's all these things are all part of it. It doesn't matter whether you have a very theoretical, very computer analyzed thing or whether you do a practical design. In any case, it falls in one of these many research categories that I've just shown you, and you can find yourself an objective. But the important thing is that you limit your objective by telling us how you're going to reach it. And this is different from what you've taught in systems engineering with mission statements and all that. So in the intervention and change, you start looking at what if we change something, what would happen? So how to distribute your air taxi fleet effectively across major cities. So there's this an air taxi that flies people who are willing to pay too much money for a single flight. How do you make sure that you don't fly empty? Because that's effectively a loss of money. So your research objective might be to make recommendations to the air company director about the distribution of air taxis by closely following and describing the current distribution and then suggesting improvement. So you look what is there and what will need to change to reach the objective of your client, namely minimum empty legs. This is how you could do it. And then the final one is evaluation. We make changes and then we have to actually check if what we did worked. The problem with that is that most people actually aren't patient enough to wait. It's like when you change something in a course, it takes 2 to 3 years for it really to settle in and everybody to get used to it. However, the efficiency thinkers would like results tomorrow. Students would also like results tomorrow, and secretly lecturers do too, because you put all the effort in. It would be really nice if it worked, but you have to be patient. So in terms of evaluation, it's really important that you do that well and that you actually back up your claims. So an airline changed from hub spoke to point and wanted to know if it actually improved the airline's revenue. That changed. There might be other things that have also improved revenue because the fuel prices went down, but it's important to see whether that specific thing did. So the research objective could be to make recommendations to an airline with regards to revenue improvement by carrying out the evaluation of the revenue since the change to point. So you look at before, you look at after, and then you say it did not improve or it did improve based on what you've observed, measured, and calculated if there was the difference was of significance. And there might be a difference, but you don't know what caused it and what the relationships are behind it. See the things we discussed in week 1. So once you've got all that, you can represent everything in a research framework, more or less from your objectives to where you're going to go. And in a research framework, you also take a little bit your scope and your research space. So let's assume that you want to know a little bit more whether a beam can do something. Let's assume that we want the beam to be the spar of the new A380 Neo that might be designed. So what do you need? So you start looking at all the things you need. I need beam theory, I need adaptive structures, I need a little bit to know about verification, validation, manufacturing, probably also a little bit about testing. That's on this side. Then you make a conceptual model of what the beam should look like. And then you're manufacturing the beam and you're going to test it. And out of the test comes a set of results that you analyze. And to validate it, you're creating a finite element model in which you simulate the test and you also get results. And you compare those two to see if everything works according to what you think worked, and then you come to your conclusions. More or less, that is the schematic representation of the research you're undertaking. It doesn't tell you exactly what it is that you're investigating. For that, we need to start looking at the research questions. Research questions, to a certain extent, can be a lifesaver in your project because basically it tells you when your project is finished. You're namely finished when you've answered all your research questions. A good research question allows for any answer. I've said this before. Yes is not the only answer to a question. No is a perfectly valid, maybe not a satisfying, but still perfectly valid scientific answer, especially if you can back it up by the data that proves that what somebody wants to do isn't possible under the conditions that you've investigated in the current in the current era. So maybe it's possible in 20, 30 years from now when there's new development, but right now isn't possible is a scientific answer. So research questions basically are questions that must be answered during the project, and if you've answered them all, you're finished. If you post them right, they actually have the information in it that is useful and necessary to actually accomplish the research objective that you set yourself out. And by having these questions, they actually help you to design the technical part of your research. So when you move to the technical design, and if you struggle with that, it's most likely that your set of research questions is inadequate. They're not complete enough or smartly formulated enough to get you to reach your objective. So what do you need to keep in mind when formulating research questions? Now, the book tells you lots about this. I'll quickly, briefly summarize it, but I think you're much better off reading it in the book and seeing the examples worked out there rather than listening to me going on about it for hours. Basically, there are 3 methods. You subdivide the research framework, as the one that I showed you before. Is it possible to simulate the finite element of a beam? All those sort of things. From the research framework come a number of key questions, and from the key questions you can have sub-questions. The other thing is, if you don't have your framework is formulated slightly different, is that you look at what are the key concepts that I'm studying, and from each key concept there's a number of sub-questions coming from each of those questions. And then you have the corroborative type of knowledge, which basically has key questions and sub-questions, and you start looking what type of knowledge do I need to solve my objective, and from there come questions rolling out. So basically, however way you follow it, one way or the other, you need to come up with research questions. I am not personally a big fan of one research question. I don't think there is a thesis possible that says just one research question. There are always underlying sub-questions. If you only have one research question, because Dr. Saunders said you had to have a research question for research methodologies, you're actually selling yourself short, not me. The reason being is that you actually haven't defined your research strict enough. So that means that during your project, you'll get stuck thinking, yeah, does that or does that not belong to my research? Does that add information to my research objective? Oh, well, maybe, I don't know. So if you have more thorough questions, you've actually mapped out what you are and are not going to study and are not going to do. So that comes me to the requirements for each research question, and they really must meet them, otherwise it really doesn't help you. It should have an efficiency and a steering function. When I talk about efficiency, that's the degree of knowledge you need and the degree to which the knowledge contributes to the research objective. The steering function is, does the question indicate what type of knowledge is required, and does the question help decide what material data needs to be gathered through the project? So think of things such as, I will find out what previous, your research question may be, what previously published literature is available on the solution method for my problem. And you should have, okay, so where do I, the type of knowledge? Comes from literature. What material data? Only the literature that helps me solve my problem. And what I want the solution methods, not the entire study. So that's a whole different thing, and that's why you need to review literature critically. So that is where you need to look at. So how do you formulate a research question? Primarily, you identify the main issue that you will investigate. So what is the key concept that is actually the focus of the work? First, try and think of this without any quantitative terms. Really try and make it as qualitative as possible, and then try to design the research question so that it links to a research hypothesis based on a quantitative evidence. So that you can say yes or no, or this much or that much, those sort of things. Also see if you can identify and incorporate the drivers in that, and formulate a link to a main hypothesis that you can actually test. And you can have multiple hypotheses in there. And similarly, also look at the knowledge capture. What knowledge do I need, and what knowledge am I going to add by doing with this research question? So those are important things to keep in mind. So the word hypothesis has fallen. So how does this work again? Well, when you formulate a research hypothesis, that really should have the missing link between the qualitatively highly intelligent research and the scientific proven quantitative research. So you think something is this way, and how do you actually prove this? Or you've deduced from literature that this might be the case, and now you need to prove it. Or you've designed something and you want to know it's working. So basically a hypothesis is a formulation that tests the proposed relationship between key variables and should really get you to an improved solution for your problem that you're looking for. This is not always 0 and 1 or yes and no, but because there are several classic structures to them. The null and alternative construct are the easiest ones. Relationship correlations are disproved or otherwise. But it could also be the if-then construct. Well, if I find this, then the solution is that. If I find that, then the solution will be something differently. And also, it might be that you want to actually see what it is that you find. I believe there is a positive relationship between the time you spend on your master thesis and the effort you put into this course. Some of you may be listening to this going, no, I don't think so. I think this doesn't make any sense. All the time that I spend on this will not help me one iota. Unfortunately, neither you or I can prove which one of us is right without doing further research. Now, I might at one point be tempted to do that, but that's a whole different project in the making. But as a whole, these are the directional and non-directional. Do I accept a positive increase? Do I expect it not to change? Or positive, but how much? Do I expect it to go down? Anything is possible. So what do you need to be aware of? Those are the pitfalls. The research questions are yours. They're not your client, not your supervisor. The research questions are the questions you, the researcher, want answers to so that you can report to the problem that your client has or the questions that your client has. When you have a few key research questions and you start finding sub-questions, there can never be one sub-question. Then it's either another key question or you haven't developed that part of your research further enough to the idea of what it is that you're investigating. Keep checking back when you formulate each question that you've actually met the requirements regarding efficiency and steering. And like any design, research questions generation is an iterative process. So check continually whether the set of research questions you've obtained actually is still within the research objective. Because it might be that you've got a change in framework or objective, and then you may need to make adjustments and repeat the steps. And the adjustments are most likely to your research question, especially if you've agreed on the objective and the framework. A good thing to keep in mind is that your research questions are smart. They should really be beyond discussion. You don't want to look back 5 months later thinking, what was it that I was thinking of when I was doing this? So they have to be specific, they have to be measurable, achievable, realistic, and time constrained. The reason I keep on bringing up time is that please realize that the current way your master's thesis is being graded is that if you overrun your master's thesis too much, it actually negatively affects your grade. Because it wouldn't be fair that you worked for 2 years and have a brilliant piece of work, whereas somebody else who can't afford to study that long is actually held that against them. That is not what it's about. It's about the project has been set for 9 months and how far can you come with your project. And if you take much longer, you will be penalized. So keep that in mind when you're setting out your objectives and your research questions. So what is an example of a research question? Well, the problem you're trying to look at is, from the objective point of view, is it possible that rocket, it's not really an objective yet, the problem you have is it possible that rocket technology can be developed in an economical, feasible manner in order to facilitate the vehicle requirements associated with moon tourism? And possible research questions could be what are the technological success factors for space tourism to the moon? That's basically what you need to research is a list of what's coming out and why. And, okay, how will then the actual situations, the next step in your research, of the current feasibility be assessed in light of these success factors? So, how can I assess this? That gives you a method, and then your next thing is, for instance, the assessment of these things. So that's how you have to look at things. Then we come to the final part, and that is a really important part. That's probably the part where communication is key. This is where you define and operationalize your research. This is where you agree with everybody who's involved in your research what's what. So you describe the content of your key concept with exact definitions. So if you talk about air travel, you define what you mean by airplane or also by hot air balloon. Make sure it's defined. if you use certain terms, if you scope, all these things, what assumptions, what limitations are you making, what are you not going to do, and why? What are you neglecting? What are the indicators and the variables you will use, and how have you defined these variables with what units to a certain extent? How will you measure those? And all these concepts and definitions that and the operationalization of it that you define and you put down on paper helps you determine the type of material you will gather, but it also helps you making sure that everybody's on the same page. If you leave it till later, you get confusion and people go, but I thought you were studying this. No, but I meant that. And that way you're sure that everybody's on the same page and you don't actually waste time in your research. So this sort of completes the conceptual research design. And in the next online lecture, I will talk about the technical research design. So good luck with finding your research questions and your objectives. And this is a good time also to test them on somebody in your group that is working on similar projects to see how they feel the questions are. Ask them to play devil's advocate and see if it's clear enough. That may help you. Good luck, and for now, bye-bye.